Okay, so this is my 4th generation preamp. I call it Fluire because this is a very special design over the past 35 years of the tube and audio file experience. The special about this tube preamp is it used the legendary Siemens C3m as the preamp tube, and it has dual rectifiers, EZ90 or 6X4. That's a US model. It's a dual rectifier powering entire tube preamp. It has the high-end Riva dual capacitor, which is a 730 microfarad, which is pretty big for preamp. Usually this is used for the power amp. It has a dedicated tube as a high voltage regulator for powering C3m. This is a 12B4, so this will provide dedicated clean power after the rectifier just for the C3m. This too, the driver for output into the power amplifier. This is made by UK GEC. The model number is A2293. This is very low output impedance, super high bandwidth, generate a lot of heat, but it can drive like any kind of amplifier, you name it, on the market. So take a quick look. So there's a power. I didn't install the volume knob because I used my DAC to do the volume control. Every volume pod or via the signal path gonna degrade the audio path. I don't need the 2 volume pops, so intentionally not to make it, but it doesn't mean I can't make it. I can add it. Yes, I can. It's optional. We can talk about it later. All right, look at the back. This is standard like 120 volt. I can make 240 volt as well, but this one is 120 volt. The heatsink is because the high power AC to DC powering up the these 2 tubes being DC rectified. So because you wanna be very quiet of the tube amp output to the power amp, so all the C3m, the major gain stage and the driver stage are powered by DC. So it's very quiet. This is input and this is output. Okay, so let's take a look at the inside. So it's my topology. All right, be careful about this. All right. So let me quickly explain this. All right. So this is the AC. When the AC comes in, right, it has a few paths. The high voltage, as I mentioned, it goes to the 2 EZ90 rectifier, and the first stage I use a very high-end that's MKP capacitor. So usually people will use electrolyte capacitor because of the price. So this alone can cost the cost is like $10. So people usually, the big manufacturer, they will use like 90 cents or $1 or $2. This kind of caps. It's easy, but this has much faster speed, much better rectification, filtering capability, and much solid and punchy sound. This is a very important as a first stage of after the high voltage power. Once it goes to the high voltage power, it goes to goes to this. All right, the power output, and goes to the choke. So the choke is very important for any tube amplifier because it will provide a low Q, a little bit slower power, so you don't have too harsh treble. It calms down, and also provide very good AC ripple rejection. The choke I use is it's pretty sizable. This also was using for a power amplifier, but I use entire, introduction, you will see I use a lot of this kind of high-end, over-spec stuff from the power amplifier or very high-end gear onto this preamplifier. Okay, so once it goes to the choke, it will go into this, the Riva, the Sweden-made capacitor, 730 microfarad as a first stage. From here, it goes to two places. One is it power up the, it goes to the another, I call this a voltage drop, to the second reservoir, the capacitor. So it goes to the second, the first path, it goes to the second, meaning this goes to this two, okay, this two. This two are the MOSFET voltage regulator. So this two specifically just serving one of each of this tube, okay? So I use very expensive high-end, architecture going to from the rectifier, MKB capacitor, choke, high reservoir, Sweden-made capacitor, voltage drop, making, of course, everything's been calculated, going to the MOSFET rectifier, regulator, and one of each MOSFET just dedicated serving one of the driver. So it's so clean, the power, very high stability, to drive any potential loads of any power amplifier in the world. So that is one path. Of course, it has a local, he's right here. These two are the local decouple capacitors, meaning it will further separating and preserve local power for those final driver to the power amplifier of the preamp output. The second path, as I mentioned, is from here, it goes directly feeding to this tube voltage regulator. So notice that the entire, like the signal output is, the signal amplification is the C3m, the legendary, German telecom post C3m tube. So those two has dedicated power regulated by this, and this two output buffer has dedicated MOSFET as a voltage regulator. We haven't stopped. I didn't stop here. Okay, so it comes from here, right? Remember, the high voltage come in, the first pass go to the high power output buffer. But you need the signal amplification, which is using the C3m. The C3m power, the raw power, is derived from this, the 12B4 tube as tube rectifier. This is a big reservoir from Siemens capacitor, and it output, it's been regulated at 220 volt, 215, I remember that, around that range, and go into this two local decouple, can further separate it, the left and right channel, so it doesn't have any crosstalk, cross feed of the noise, minimize the noise from left to right channel, talking to each other. So I use a very high-end way of doing this is the local decoupler. So after the local decouple, one of each goes to not the tube directly, but it goes to the most important part of this preamp is this. You see the resistor here, and the other one is right in the middle, if you see it down there. All right, so 1, 2, 3, 4. So a pair, the second pair, forming a cascade CCS, constant current source. It provides the highest bandwidth possible for the tube to swing. It provides the widest range for the tube to amplify, so it doesn't feedback or doesn't provide any extra constraint to the tube. So this is very uncommon. So the common way is just use a resistor like this, the big one resistor, as load for the the gain stage, which is in this case C3m. I use a very, very high-end way of doing the replacing the traditional R. We call this R load, resistor load, as an active load from the cascading CCS. Each one drawing about 15 amps, constantly feeding one of the C3m2. Okay. All right. So that is the second power path. All right. The signal is coming from here. So I made a very special arrangement of the making sure the incoming RCA noise is being, blocked. That's why I use this silver mica capacitor, the right value to eliminate anything above about 200K and above noise. So you will not hear like if your house or your power external in the house is not so clean. This definitely can help to keep this high frequency noise out. It fits into the C3m and it amplifies via these two cascading CCS active low, and the output is using this legendary Sprock made PIO paper in oil capacitor to the next stage, which is the GEC A2293, the power tube output. So you notice I use 0.47, which is pretty good enough, along with the RC network. It gives you very high bandwidth, very reasonable low frequency cutoff, about like 1 or 2 hertz. Like, people can not hear usually anything below 20 hertz. So I set a cutoff, below like 2 hertz. So it's a very, very reasonable setting. It will not drag too much, bass, decay.